Hello, good day. I'm Sharvin Abbas and I am the representative of my group to present and discuss to you about the topic that has been assigned to us. So let's start about importance of transportation, which was prepared by my groupmate Joshua Bujungan. Transportation, basically the movement of goods and persons from place to place, and the various means by which such movement is accomplished. Transport facilitates tourism and travel by allowing people to travel to destinations they desire. Without transportation and the advances that have resulted, we would not be able to live in the world we have today. It is necessary for mobility, travel, and economic activities. We would not be able to travel as easily as we do now without cars, planes, trains, and buses. Transportation investments that are well made reduce the cost of moving people and goods. This economic productivity, which is essentially defined as the amount of goods and services produced per dollar invested by the private and public sectors. Improved production in turn contributes to an improved standard of living, tapping natural resources and markets and maintaining a competitive edge over other regions and nations are linked closely to the quality of a transportation system. The speed, cost, and capacity of available transportation have a significant impact on the economic vitality of an area and the ability to make maximum use of its natural resources. It is difficult to overstate the influence that highway transportation has on the economy of nations. Highway systems have direct effect on industries that supply vehicles, equipment to support highway transportation, and industries that are involved in highway construction and maintenance. Highway systems are also vital to manufacturing and retail supply chains and distribution systems and serve as a regional and national economic engines. Good transportation, in and of itself, will not assure success in the marketplace, as the availability of transportation is necessary but insufficient condition for economic growth. However, the absence of supportive transportation services will serve to limit or hinder the potential for a nation or region to achieve its economic potential. The survival of modern economies is predicated on efficient and reliable supply chains. Industries have become increasingly dependent on their supply chains to reduce costs and remain competitive. As an example, most manufacturing industries today rely on just-in-time or JIT delivery to reduce inventory-related costs, which can be a substantial percentage of total cost in many industries. The idea of JIT delivery is that the materials required for production are supplied just before they are needed. While such a strategy significantly reduces inventory costs, it requires a very high degree of certainty that the required materials will be delivered on time. It has long been recognized that highway construction and improvements to the highway network can positively influence economic development. Such improvements can increase accessibility and thus attract new industries, inspire local economies. To be sure, measuring the economic development impacts of specific highway projects is not an easy task because such measurement must be made in the context of regional and national economic trends. Still, the effect that highways can have on economic development is yet another example of the far-reaching economic influences of highway transportation. Changes in transportation sources that could positively or negatively affect the preferences, well-being, behavior, or perception of individuals, groups, social categories, and society in general are referred to as social impacts of transportation in the future. So, the next topic we have is transportation history. And it was prepared by my groupmates Stephanie Joanna Casil and Roger Cañada. Spanning from 4000 BC to the present day, the history of transportation is a fascinating topic that can expand your children's understanding of transport and travel, and how it became what we know today. In 1794, the Lancaster Turnpike, the first toll road, was built to connect the Pennsylvanian cities of Lancaster and Philadelphia. In early 18th century, the travel was by horseback or an animal-drawn vehicles on dirt roads. In 19th century, the expansion of U.S. territorial boundaries and the population increased because of the transportation. The transportation was continued to expand worldwide. Then the Erie Canal boom was constructed during 1817 and was completed in 1825 and other inland waterways, but an era of canal construction began in 1820s. In 1830s, the transportation of goods in canal was replaced by railroads because railroads could be constructed almost anywhere in the vast and undeveloped land at a much lower cost than canals. So the era of the canals came to end. In second half of 18th century, railroads were emerged of mode of transportation because the railway expanded to the entire continent. The railroad mileage reached its peak for about 265,000 miles by 1915. So, the city demand for improvements in urban transportation systems because each decades the population growth continues within the city. Horse-drawn carriage was the first vehicles for transport in the city and later traveled in steel tracks, until the city developed cable cars, electric streetcars, underground electrified railroads, and bus transportation. During the 20th century, the invention and development of the automobile created a revolution in transportation in the United States. The invention of the automobile together with the airplane has changed the way they travel within and between cities. In the 20th century, the Wright brothers from Ohio changed the world by building the first powered airplane, the first flight taking place in 1903. Both World Wars I and II were catalysts in the development of air transportation, to carrying a mail to support the government industry. Commercial airline passenger service began to grow until the expansion of air transportation was phenomenal. So let's move on to the transportation employment, which this was prepared by my groupmates Aris Bughaw and J. Maribel Ayag. So, transportation employment. Employment opportunities exist in several areas of transportation, including business, logistics or supply chain management, vehicle design, and manufacture, provision of services related to the transportation, and the provision of the infrastructure required if vehicles are to function as intended. The physical distribution aspect of transportation, known as business logistics or physical distribution management, is concerned with the movement and storage of freight between the primary source of raw materials and the location of the finished manufactured product. Logistics is the process of planning, implementing, and controlling the efficient and effective flow and storage of goods, services, related informations from origination to consumption as required by the customer. Vehicle design and manufacture is a major industry in the United States and involves the application of mechanical, electrical, and aerospace engineering, as well as those of technically trained mechanics and workers in other trades. The service sector provides jobs for vehicle drivers, maintenance people, flight attendants, train conductors, and other necessary support personnel. Other professionals such as lawyers, economists, social scientists, and ecologists also work in the transportation fields when their skills are required to draft legislation, to facilitate right-of-way acquisition, or to study and measure the impacts of transportation on the economy, society, and the environment. Although a transportation system requires many skills and provides a wide variety of job opportunities, the primary opportunities for civil engineers are in the area of transportation infrastructure. In this role, they are responsible primarily for the planning, design, construction, operation, and maintenance of the transportation system within the United States. The transportation engineer is the professional who is concerned with the planning, design, construction, operations, and management of a transportation system, as illustrated in the figure. Transportation engineers are typically employed by the agency responsible for building and maintaining a transportation system, such as the federal, state, or local government, a railroad, or a transit authority. They also work for consulting firms that carry out the planning and engineering tasks for these organizations. During the past century, the transportation engineers have been employed to build the nation's railroads, the interstate highway system, and rapid transit system in major cities, airports, and turnpikes. Each decade has seen a new national need for improved transportation services. It can be expected that in 21st century, heavy emphasis will be placed on the rehabilitation of the highway system, including its surfaces and bridges, as well as on devising a means to ensure improved safety and utilization of the existing system through traffic control, information technology, and systems management. Building of roads, highways, airports, and transit system is likely to accelerate in less developed countries, and the transportation engineer will be called on to furnish the services necessary to plan, design, build, and operate highway systems throughout the world. Each of the specialties within the transportation infrastructure engineering field is described next to transportation planning, transportation and infrastructure design, highway construction, traffic operations and management, maintenance, operation and management. So let's move on towards urban transportation challenges. This is only the part 1 and this is prepared by my groupmates Noel C. Alaban. Cities are locations having a high level of accumulation and concentration of economic activities and are complex spatial structures that are supported by transport systems. The larger the city, the greater its complexity and potential for disruptions, particularly when this complexity is not effectively managed. One challenge is the traffic congestion and parking difficulties. One of the most prevalent transport problems in large urban areas, usually above a threshold of 1 million inhabitants. It is particularly linked with the motorization and the diffusion of the automobile, which has increased the demand for transport infrastructures. Another challenge is longer commuting. On the par with the congestion, people are spending an increased amount of time commuting between work and residence. Also, it caused by the distance of the workplace or the traffic that can be seen in the crowded environment. Another challenge is public transport inadequacy. Many public transit systems or part of them is over or underused during peak hours. Crowdedness creates discomfort for another commuter. With the world present status, it is not good to have a crowded commuter in the public, especially in rush hours. Another challenges is difficulty for non-motorized transport. These difficulties are either the outcome of intense traffic, where the mobility of pedestrians, bicycles, and vehicles are impaired due to many motor transport like cars, truck, and motorcycles. Non-motorized transport is hard to compete and sometimes not allowed in the highway due to possibility of accident. Another one is the loss of public space. The majority of the roads are publicly owned and free of access. Traffic flows influence the life and interaction of the resident and the usage of the streets. Increase of traffic impact on the public activities, which one crowded the street such as markets, agoras, parade, games, and community interactions. These are gradually disappear to be replaced by automobiles. And the next one is high infrastructure maintenance cost. Cities facing the aging of their transport infrastructure have to assume growing maintenance costs, as well as pressures to upgrade to more modern infrastructures. The more extensive the road and highway network, the higher the maintenance cost and its financial burden. The same applies to public transit infrastructure that requires a system-wide maintenance strategy. Continuation of urban transport challenges. These are prepared by Ryan Fred Desser. Environmental impact and energy consumption. As numbers of urban transportation are increasing, the more it has become a serious impediment to the quality of life. As mentioned, noise is one of the impacts that urban transportation have. In this matter, the noise generated by vehicles such as buses, trains, motorcycles, etc. makes destruction to the people nearby. On the other hand, the emission of air pollutants from fossil fuel combustion is the major cause of urban air pollution, which results to long-term health effects such as heart disease. Air pollution can also cause long-term damage to people's nerves, brain, kidneys, liver, and other organs. Some scientists suspect air pollutants cause birth defects. Carbon dioxide or CO2 produced by the combustion of fossil fuel in internal combustion engine is the predominant GHG emitted by the transport sector. To see how much carbon dioxide is emitted by urban transportation, here is the pounds of CO2 emitted per million for various fuels, as shown in the table. These amounts of fuels coming from various coals that are generated by respective vehicles are harmful, which emit GHG that will eventually become greenhouse effect. Another challenge is accidents and safety. Road accidents currently rank ninth as cause of deaths worldwide. This is because many of the people killed are relatively young. Road accidents already rank second in terms of reduction in life expectancy. Worldwide, the number of people killed in road traffic crashes each year is estimated at almost 1.2 million, while the number of injured could be as high as 50 million. The various causes of road accidents are road users, vehicle, road condition, road design, and improper location of advertisement boards, gate of level crossing not crossed when required, and etc. Accidents and safety. Growing traffic in urban areas is linked with a growing number of accidents and fatalities, especially in developing countries. Accidents account for a significant share of recurring delays. The table shows the comparison of leading causes of death in 2004 and in 2030. As you can see, in 2004, road traffic injuries ranked 9 as cause of deaths worldwide and are expected to rise to 5th by the year 2030 by 1.4%. If this challenge or problem will not be addressed, let's expect for the worst and dangerous highways in the future. Another one is the land consumption. the territorial imprint of transportation is significant, particularly for the automobile. By observing the spaces covered by highways, the lands consumed by highways or transportation sector are massive. In fact, between 30 and 60% of a metropolitan area may be developed to transportation, an outcome of the over-reliance on some forms of urban transportation. There may be several steps between a transport planning decision and its ultimate effects, and a particular planning decision can have a variety of impacts and costs as shown in the table. Reduced open spaces, increased flooding, stormwater management costs, reduced groundwater recharge, and aesthetic degradation. And also, in longer travel distances, more total vehicle travel, reduced accessibility for non-drivers, which is inequitable, increased vehicle traffic and resulting external costs. Another challenge is the freight distribution. Globalization and the materialization of economy have resulted in growing quantities of freight. As freight traffic commonly shares infrastructures with the circulation of passengers, the mobility of freight in urban areas has become increasingly problematic. Here are some of the issues and challenges of freight distribution in urban transportation. On the issue of freight volumes, the growth of the amount of freight circulating within the urban areas has exacerbated congestion as goods movements, like passengers, contribute to congestion. Urban freight distribution commonly accounts for the last mile in the contemporary supply chains, but this takes place in settings where many constraints are exacerbated. In the issue of nature of freight distribution, urban freight distribution is subject to smaller volumes with the time-sensitive freight necessary to replenish a recurring demand as inventory levels in urban stores, particularly those of small size, tend to be low. Since urban areas are large consumers of final goods, the issues of reverse logistics deserves attention in the form of the collection of wastes and recycling. From a social standpoint, the interaction between people and freight in these cities create many disturbances related to health and safety. In several cases, the expansion of freight-related activities and the growing intensity of urban freight movements can be a source of competition for the usage of scarce urban land and conflicts between freight and non-freight stakeholders. From your regulatory perspective, urban areas are highly constrained with a variety of rules related to zoning, emission, and even access condition to roads and terminals. High population densities imply a low tolerance for infringements and disturbances brought by freight distribution and are thus prone to regulatory pressures. Another challenge is automobile dependency. Rising automobile mobility can be perceived as a positive consequence of economic development. The acute growth in the total number of vehicles also gives rise to congestion at peak traffic hours on major thoroughfares in business districts and often throughout the metropolitan area. The majority of households owns automobiles and rely on them for most trips. Land use patterns are easily accessible by automobile, but not by other modes. Policies favor automobile travel, and few resources are devoted to non-automobile transportation. Although consumers have many choices when choosing an automobile and vehicle services, they often have viable alternatives to driving for mobility. And now let's talk about the public transport demand in the Philippines, which was prepared by my groupmate Carl Justin M. Calunsag and Christian Jan Ariola. Public transportation provides commuter with a convenient method to reach their destination faster and cheaper compared with private vehicles. However, this is not always the case for Philippines because Many Filipinos have negative perception of using public transport. Public transportation consists of a variety of modes in the Philippines: jeepneys, buses, tricycle, commuter trains, streetcars and trolleys, van pool services, ferries, and water taxis. Transportation in the Philippines covers the transportation methods within this archipelagic nation of over 7,500 islands. From a previously underdeveloped state of transportation, the government of the Philippines has been improving transportation through various direct infrastructure projects, and this includes an increase in air, sea, road, and rail transportation and transport hubs. Our public transport system is deemed unsafe, unhealthy, unreliable, and uncomfortable. PUBs and PUGs serve 67% of demand but uses 28% of road space. PUGs dominate road-based public transport, 180,000 PUGs nationwide. 90% are 15 years old and above. 17% ambient air pollution in Metro Manila, and up to 80% in other cities due to PUGs and PUG passenger 10 times more likely to get into accident than private car riders. Environmental soundness: public transport vehicles with combustion engines must have low emissions, as proven by compliance with Euro 4 emission standards. Euro 4 is a globally accepted European emission standards for vehicle. In safety, all vehicles and services shall comply with national standards and international vehicle safety conventions. In security, public transport vehicles may install CCTVs, GPS, and dashboard camera. In comfort and convenience, the vehicle is fitted with comfortable seats where passengers are able to relax, rest, and productive during the journey. Public transportation before and now. So in comparison, before, no government-led planning, widespread competition among various transportation modes, overlapping routes, no hierarchy of modes, low capacity of vehicles in high demand areas leading to reduced road capacity, prevalence of low and oversupply of public transport. Now, most of the vehicle is implemented and are environmental friendly. Road widenings applied, strictly implementing the rules and regulation in the streets. Accidents are not prone anymore because there are so many projects of the administration through the Build program of the government. So this is the last topic assigned to our group, which is the road density of the Philippines. This was prepared by my group mates Amadrida Arani and Archibald Andrada. So, what is road density? Road density is the ratio of the length of the country's total road network to the country's land area. The road network includes all roads in the country, motorways, highways, main or national roads, secondary or regional roads, and other urban and rural roads. In 2003, road density for Philippines was 67.3 km per 100 square kilometer. Though Philippines' road density fluctuated substantially in recent years, it tended to increase through 2000 to 2003 period, ending at 67.3 km over 100 square kilometer in 2003. Road density is a simple indicator of the concentration of roads in an area. The road density can be determined for road segments that have characteristics that are attribute, like road segments with 100-meter buffer or stream channels. Road density maps can be created for specific areas such as watershed or buying using an ARC macro language program or AML. It can also be used in combination with other layers such as habitat type. So the table presented here is the data about the road density in different parts of our country. It is segregated according to regions. The data in the table are from year 2005, 2006, and 2008. For further look on this table, it can be found in the PDF posted by Sir, which is the Transportation Planning in the Philippines, page 2 to 17. So the table 2.17 presented above, it presents the data on road length and road density. The cities of Manila, San Juan, and Makati in Metro Manila have the highest road densities with values of 19.64, 14.14, and 10.54 km per square kilometer, respectively. Outside Metro Manila, General Santos has the highest road density at 15.4 km per square kilometer. What it technically means is that the city of Manila, San Juan, and Makati have a number of roads constructed within their cities compared to other places in our country, which can be seen according to our data about road density. The growth of roads in these cities may be due to their booming economy and population. Hence, LGUs in those cities aided transportation of goods and services by planning to maximize road construction in their area. So, how is road density measured? Road density is measured using total length of roads per 100 square kilometer of area. Which is the lowest road of the density? According to Hamid, at present there is 1,000 kilometers of length in Kashmir, but as per national figures, Hamu in Kashmir has the lowest road density in India. So, in the Philippines setting, what is the road density of the Philippines? The road density of the Philippines is 22.4 km per 10,000 persons. The population road density of the Philippines is estimated at 22.4 km per 10,000 persons. And that concludes our presentation for today. I hope that you learned a lot. Once again, I'm Sharvin A. Abes, the presenter of Group 1. Thank you for watching and listening. Have a good day.